Hello good day viewers. In this tutorial we are going to find a solution to this interesting problem. We asked to find the values of b for which the equations have two solutions. You can see the two equations here. Y equal to x squared plus b, 2y equal to x minus 1. This is quadratic while this is a linear equation. Before we start, let me show you what this means. So first we have y-axis as well as x-axis. Let me start with the linear equation. Let us locate y-intercept by setting x equal to 0. If x equal to 0, we have 2y equal to negative 1. If you divide both sides by 2, you have y to be negative 1 divided by 2. So the graph will cross negative 1 over 2. Maybe it is halfway here, negative 1 over 2. And if you construct it, it will be somehow like this. A straight line, right? But what about the quadratic? Though we don't know the value of b, but we know how the graph of x squared looks like. It is somehow like this. It passes through the origin and takes a turn. Whether the graph is going down or up, it depends on the value of a. But for you to get solution, the two graphs must intersect, right? And if you want them to intersect, this curve will have to be somehow like this, so that you have two intersection points. So we want to determine that value of a that will shift this graph downward so that it intersects with the linear equation. And therefore, that value of b must be negative value, right? So how can we solve it? Since we have y here and we have y equal to this, we can substitute equation 1 into equation 2. So our equation becomes, the second equation is 2 multiplied by y, and y is x squared plus b, and this is equal to x minus 1. If you expand, you have 2x squared plus 2b, and this is equal to x minus 1. Let us further rearrange this. If you take this one to the other side, it becomes negative. We have 2x squared minus x. Then we have our constant here, plus 2b. And if negative 1 crosses over, it becomes positive 1. And the whole of this equal to 0. These are constants, where a, which is the leading coefficient, is 2. b, which is the coefficient of x, is equal to negative 1. And c, which is the constant, is equal to 2b plus 1. So remember the discriminant d is equal to b squared minus 4ac, right? And quadratic equation has different nature. It depends on the value of d. If d is equal to 0, you will always have one solution, a repeated root. And if d is less than 0, we have no real solution. While if d is greater than 0, we'll have two solutions, real and distinct. So therefore, we need a value of d that is greater than 0. Now let us substitute. B squared, we have negative 1 squared, minus 4 times a is 2, times c is what? 2b plus 1. We want a situation whereby this will be greater than 0. Negative 1 squared is 1, minus 4 times 2 is 8, multiplied by 2b plus 1, greater than 0. 1 minus 8 times 2 is 16b, minus 8 times 1 is minus 8. This must be greater than 0. You can see that 1 minus 8 is negative 7. We have minus 7, minus 16b, greater than 0. We may decide to take negative 7 to the other side. We have negative 16b to the left, greater than negative. Okay, it will become positive, right? Positive 7. And now from here we can divide both sides by negative 16. Negative 16. So that to the left hand side we only have b less than negative 7 divided by 16. We have greater than here, but this must be less than because we divided both sides by a negative number. And hence, these are the range values of b that will satisfy the equation in order to have two solutions. And this is approximately negative 0.4. So it means the moment you get negative 0.5, though this will not satisfy because they say it must be less than. So another value that is less than this one is negative 0.5. The moment you substitute a equal to negative 0.5 and solve them simultaneously, you're going to obtain two solutions. So this is exactly what we are expected to obtain. That is b less than -7 divided by 16. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.